Good morning. Today we will be continuing the numerical problems in power system analysis, and in this lecture we are going through the problems in economics of power system. So this is our first problem. Fuel cost of an alternator is expressed as 0.12 into P square plus 20P plus 40 rupees per hour. Capacity of the alternator is 200 megawatt. Calculate IC. IC means incremental cost, incremental fuel cost, and FC, fuel cost. FC is fuel cost. So IC is what? IFC, incremental cost, and FC is what? Fuel cost. When the alternator is loaded at 75% of its capacity, what is the incremental cost and fuel cost when the alternator is fully loaded? So this equation is what? Fuel cost equation. So it is giving the fuel cost of the machine. So fuel cost is 0.12 into P square plus 20P plus 40. Fuel cost equation F or C. Now from that you can find the incremental fuel cost. So fuel cost is this. How we are finding the incremental cost? Incremental cost is what? Incremental cost is dF by dP. dF by dP. So just differentiate with respect to P. It will give you what? Incremental cost. So differentiating this will give you 0.24 plus P plus 20. 75% loaded means its loading capacity is what? 200 megawatt. If it's 75% of the loading means 0.75 into 200 will give you 150. Will give you 150. 75% means what? You have to multiply with the 0.75 into 200. 0.75 into 200 will give you 150. So you just substitute in this. 0.24 into 150 plus 20 will give you 56 rupees per megawatt hour incremental fuel cost, and substitute in this equation 0.12 into 150 square plus 20 into 150 plus 40 will give you 5740 rupees per hour. If it is fully loaded means 100%, you have substitute 200. 0.24 into 200 plus 20 will give you 68 rupees per megawatt hour, and this 200 square will give you in this first equation, if you are substituting, it will give you 8840 rupees per hour. So which one is more economical? Which one is more economical? If it is loaded at 100%, will give you you have a production cost of per hour for this megawatt hour production, you are having a per hour you are having a cost of 68. For this you are having a cost of 56 only. So this is more economical if 75% loaded. So from that incremental fuel cost equation you will be getting this information. How much will be the cost per hour for 1 unit, 1 megawatt. Okay. Now going to the next problem. Fuel inputs are F1 equal to 0.2 P1 square plus 40 P1 plus 120, and F2 equal to 0.25 P2 square plus 30 P2 plus 150. Determine the economic operation module, economic operating schedule, and the corresponding cost of generation if the maximum and minimum loading of each unit is 125, demand is 180 megawatt, and the transmission losses are neglected. We have considered two cases. In one cases we have neglected the transmission losses. In the other case we have considered the transmission losses. So here the transmission losses are neglected. If the load is equally shared by both the units, determine the saving obtained by loading the units as per equal incremental production cost. Now we have to employ the equation for how we, if the losses are neglected, what is the condition for optimum schedule, optimum economic operating schedule. Incremental cost of each units are same, and it is equal to what? Lagrangian multiplier. So here the incremental cost of each units are equal. That means we have to find dF1 by dP1 and dF2 by dP2. We have to equate that, and also we know that demand is 180 means what? P1 plus P2 equal to 180. So here first you are finding dF1 by dP1 differentiating with respect to P1, and dF2 by dP2 differentiating the equation of F2 with respect to P2, and these two are equal. So you will be getting from this relation, you will be getting P1 plus P2 equal to 180 and P1 plus P2 equal to 180. That means total generation equal to total demand. If losses are considered, that equation will not satisfy. You have to employ the another loss also considered. Here you will be getting two equations. This is one relation and this is the second relation. By solving these two, you will be getting P1 equal to 88.89 and P2 equal to 91.11. Now the new cost of generation, what will be the cost of generation? You have to find the F1 and F2. So substitute the value we got for P1 and P2 in that relation. P1 equal to 88.89 and P2 equal to 91.11. Then you will be getting F1 and F2. So total cost will be sum of these two, 10,214. Now if the load on each load is shared equally, this is another case B. So if load is shared means P1 equal to 90 and P2 equal to 90. In that case, here you substitute P1 equal to 90 and here P2 equal to 90. Then you will be getting F1 and F2. You're taking the sum will be give you what? 10,215 per hour. This is 10,214.43. So which one is lesser cost will be for optimum economic schedule. If load is shared, its cost is more than this. This is per hour only. So you can save rupees 0.57 per hour. So if you are running for more than 1 hour, more than 1 day, for an year, like that, annually if you are finding, it will be more. That cost, that savings will be always more. Now consider this third question. F1 and F2 is given here also, and maximum and minimum loads on the units are 100 megawatt and 10 megawatt. These are the limits actually. Whatever the values we are getting should be in between these two. That values of the loads P1, P2, if you are finding, that should be in between these two, and determine the minimum cost of generation. That means optimum schedule for the following load. Cost of the fuel is rupees 2 per million BTU. So actually from this time 12 to 6 you are having a load demand of 50 megawatt. 6 AM to 6 PM you are having a demand of 150 megawatt. So from the fuel input characteristic you will be getting dF1 by D2, dP1 and dF2 by dP2. If the load is 50 megawatt, so two cases are there here. One is 50 megawatt. In these two conditions, load is 50 megawatt. Here it is 150 megawatt. If it is 50 megawatt, in both cases dF1 by dP1 equal to dF2 by dP2, but P1 plus P2 will become what? 50. That is only change. And you are considering this dF1 by dP1 equal to dF2 by dP2, then you will be getting this relation 0.048 P1 plus 8 equal to 0. So you will be getting P1 plus P2, and considering these two are solved, then you will be getting 15.625 and 34.375, and substituting in the fuel cost equations you will get these relations. If the load is 150, the similar procedure only, P1 plus P2 equal to 150, then you will be getting P1 equal to 78.126 and P2 equal to 71.874, and F1 equal to F1 and F2 you can find, and total cost you can find by using this relation. Now, so in this question number 4, you can see a 2-bus system is shown in this figure. If a load of 125 megawatt is transmitted from plant 1 to the load. So this is a plant 1, this is plant 2. Load is concentrated here. That means plant 2 has directly distributed the load to the generated power to the load. That is the difference in this question. If a load is here, means plant 2 can directly distribute the load. That means there will be no losses related to this plant. But for the plant 1, if a load of 125 megawatt is transmitted from here to here, a loss of 15.625 megawatt is incurred. Determine the generation schedule and the load demand if the cost received power is Rs 24 per megawatt hour. Solve the problem using coordination equations and the penalty factor approach. Actually, not required. This is not required. You just concentrate on this penalty factor method. Incremental production cost of the plants are given like this. So this is the speciality one. So in this here the load is concentrated here. That is the speciality of this question. So from 1 to 2, if 1 to this load, if we are transmitted, there will be a loss. But if 2 to this load, there is no loss. That means whatever the loss or loss coefficients related with this plant 2 will be equal to 0. Now what is this cost received by the plant will be Lagrangian multiplier. You just note down that cost received by a plant rupees 24 per megawatt hour is what it is given as lambda, Lagrangian multiplier for the system. Now you look into this here. Condition for optimum operation is what? df1 by dp1 into L1 equal to df2 by dp2 into L2 equal to lambda. This is the condition if you are considering the losses. If not, losses are not considered, means df1 by dp1 equal to df2 by dp2 equal to lambda. Now for the second unit, loss equal to 0. Why? No transmission of power and the load concentrated at unit 2. That means B12 equal to B21 equal to B22 equal to 0, and the total losses equal to B11 P1 square plus 2 into B12 P2 plus B22 P2 square. We already discussed about this. It will be only B11 P1 square term will be there. Now we are considering first for the plant 2, df2 into dp2 into L2 equal to lambda. Okay. Lambda is cost received by the plant rupees 24 megawatt rupees 24 rupees per megawatt hour. df2 by dp2 equal to what? df2 by dp2 is given in our question 0.05 p2 plus 20. So 0.05 p2 plus 20. Penalty factor. So we got this relation. Penalty factor L2 equal to 1 by 1 minus dou PL by dou P2. You can check that. We discussed about that. It is equal to 1. Why this is 1? Because dou PL by dou P2 equal to 0. What we have to do? PL is equal to B11 P1 square has to be differentiated with respect to P2. So with respect to P2, then it will be equal to 0 because there is no terms containing P2 here. So that dou PL by dou P2 will become equal to 0, and penalty factor L2 will become equal to 1. 1 by 1 minus 0 equal to 1. So you can write like this from this df2 by dp2 into L2 equal to 1. So df2 by dp2 equal to lambda 0.05 into P2 plus 20 equal to 24. From this you can find P2 equal to 80 megawatt. Now we are going for the first unit. This is for the first unit. So for the first unit, 1 by 1 minus dou PL by dou P1. What is dou PL by dou P1? You have to differentiate this B11 P1 square. B11 P1 square. You can see B11 P1 square is differentiated with respect to P1. So what you will be getting? You will be getting 2 into B11 P1. 2 into B11 P1. So you look here. Actually, it is explained here in this first part. Only this is required here. You just look into this part. So B11 P1 square, B12 equal to B21 equal to 0 and B22 equal to 0. Now B11, it is given like if a power load of 125 megawatt is transmitted from plant 1 to the load, a loss of 15.625 megawatt occurs. So you can see here, if P1 is 125, a loss PL equal to 15.625. So that data is given there. So if P1 equal to 125, PL equal to 15.625, then you will be getting what? B11 equal to 0.001. And using solution penalty factor method, 1 by 1 minus dou PL by dou P1. So 1 by 1 minus 2 into B11 P1. Because if you are differentiating this, you will be getting 2 into B11 P1. So 1 by 1 minus 0.002 into P1. Okay, this is not required actually. And you just look here. So it is 2 into B11 P1. 1 by 1 minus 0.002 into P1. So df1 by dp1 into 1 by 1 minus 0.0022 into P1 equal to 24. You just solve this, you will be getting P1 equal to 123.28. So this is already discussed earlier. So P1 equal to 123.28 and P2 equal to 80 megawatt. So with this I am stopping this lecture, and the next module will be explained in the next video.